Hello.
Good evening, sir.
Yeah, good evening to all.
Good evening, sir.
Good evening. Can you see my screen?
Yes, sir.
Yes, sir.
Okay, so we will continue today regarding the quantity estimation of the steel and concrete for this. So last time we have seen this beam. I think this B6 simply supported beam we have seen. So today we will see these continuous beams and the detailing regarding that. Okay. So you can understand it is a continuous beam and having fixed support. Whenever beam is resting on the column, it is fixed support, and here also it is resting on the shear wall or lift wall, we can say. So it is also fixed. So all joints are fixed joints, and therefore you know that there will be negative moment over here, fixed end moment like this, right? And there is a schedule given here regarding these beams. So beam B1 and B2 we will calculate the quantity. So we'll do one thing. These are the reinforcement details of the beams, and you know that whenever we have a schedule, we refer the standard drawing for that. So if you see this, last time we have seen this simply supported beam detail. Now in this case, you can use this continuous beam detail. So continuous beam, in this case, it is a totally continuous. There is a column here, here, and it is still continued here to the next. And if you see this detail, then it is two span continuous. So these two ends are, we can say, this is the end and this is a mid support. So we will copy this. Okay, so you know that there is a lift wall over here, and the columns are, let's see, which are the columns? C1, C2, and lift wall. Okay. So this is your C1. This is your C2 column, and this is your lift wall. Okay. And this beam is B1, and this beam is B2. Okay. Now we will write down the steel, which is here as per the schedule. So you know that G bar is top continuous. So top reinforcement continuous, which is 2T8. Okay. Then H plus G. G is already there. H is nothing but your extra support, extra over supports on the top side. So it is, we can say, H. So this H is now it is mentioned here on column C1, 3T12. Okay, then for B1 beam, what is the bottom continuous? E bar. So E bar is bottom 2T16. And there is a F bar, which is 1T16, curtail bar, 1T16, right? Now here also there is a H bar. So this H bar is, what is that? On column C2, top extra support, 3T16. I hope you are getting this, what I'm trying to say. H is on the top extra support. It may be columns or walls. So this is the steel. Now in B2, you can see B2 E bar is, what is this E? 2T12 at the bottom. Then G bar is 2T8. And yes, E bar, there is no E bar. So E is 0. Let me write it. There is no E bar here. And H bar on lift wall, how much is this? 3T12. Now what we require for a quantity calculation, we want the dimensions. So what is L1? So L1 is, go into the drawing. L1 means clear distance between the supports. So from here to here, see this support, column face 4.6. I will round for the calculation purpose. 4.6. L1 is 4.6. And what is L2? Face to face, internal face of the column. So from here to here. All right, check it out. From here to here. 2.9. L2 is equal to 2.9 meters. Now we want the dimensions of the columns also like this, right? So this dimension, then column dimension, this dimension, width, and this wall, lift wall dimension. What is that? This is 230, this one is 600, and this one is lift wall thickness 200, 230, 600, 200. So I will write in meters, 0.23 meters, 600, 0.6 meters, and this one is 0.2 meters lift wall. Okay, so these are the dimensions which we want. Anything else missing for quantity calculation? I think everything is over now. Okay, now let's do the calculation. So first of all, we will go do the calculation of beam B1. So beam B1. What to calculate first? From top or bottom, let's say. Okay, so let's say E is equal to, what is the quantity of E? So you want length. So whenever we calculate the quantity, it is L into weight per meter. So what is the L for E bar? Yes, we want the depth of the beam also for this, right? ये कितना depth है B1 का? 450.45 meters. And this is also 0.45 meters. So what is the length of E bar? Will it be in mm? Will be easy thing to understand, right? I think we will do the calculation in mm and we'll finally convert in meters. I think so. So tell me. और ये भी आसान है ना? So shall we do in meters or mm? What are you comfortable in? Hello?
MM, sir.
Oh, okay, mm, fine. So E bar, now E, tell me, what is this? You know this 4600, 4.6 meters. So 4600, now, do you know the location of E bar here in this column? Where we cut the bar E in this column. So we generally cut on the outer face like this, please keep in mind. And this bar, this E bar, we will curtail to this side, right? So that is important to understand. You should know where the bar will stop. So it will stop like this. Many times, if the bar is having more length, contractor will continuously pass this, provided the bar diameter is same. In this case, it is 16 mm and it is 12 mm. So we cannot pass in the next beam. So it will be till here. Now what will be the dimension? So 450 minus double cover, right? Cover is 25 mm. 25 yen, I think. Double cover, then plus this one, 230 minus cover. So we have calculated this and this portion. Now clear distance plus 4600 plus this one 600 minus cover. I hope all of you are getting this. समझ रहे हैं सभी को क्या कर रहा हूं मैं? So what is the value? कितना आ रहा है ये?
Five 5780.
5.78. I will write in meters directly. Okay. Then this is your T16 bar. Then curtail bar is your F bar. F bar will be how much? So it is easy. If you know the L1, you know that 0.1 L1 from here and 0.15 L1 from here. So that means we will subtract how much? 0.25 L1 from L1. So it will be 0.75 L1, right? Getting this? समझ रहे? 0.75 L1. 0.75 into 4600. ये भी T16 है. Then G bar, ये बताओ कितना है? G bar will be 2T8. So T8, G is 2T8. So G length, I think, will it be same like this E bar? So this top bar also will correct. We will stop here. So I think it is exactly same like E. इसका कितना आ रहा है? F का?
Three 450.
Now we will calculate the H bar, which is extra over support on C1. Okay, which is how much? कितना है वो हमारा? 12 bar है. T12. HC1 is 3T12. So what is the length? 0.25 into 4600 plus 230 minus 25 plus 450 minus 25 minus 25. This length and this length.
One 755.
Then we will go to the okay. We will take this H bar on C2. So how much is this? 0.25 L1 here and 0.25 L2. So it will be 0.25 into 4600 plus 0.25 into 2.9 meters, means 2900 plus how much? 600. From here to here, this total length, right? So कितना रही है? H on C2. What is the bar? 16 bar.
2.475 meter. 475.
So yes, we have done this. Now we will go to the beam B2. So again, E bar will be bottom bar, bottom pull, right? So we will have till this point, and again this. So it will be something. क्या आएगा इसका? $600 minus 25 plus 2900 plus 200 minus 25 plus 450 minus 25 minus 25. So this is bar. Okay, this is, sorry, it should be ये E bar है ना. So E bar for beam B2. Then we will have F bar. F is it E or F? Yeah, F लिखना था मुझे यहाँ. F is 0. E is full bar, right? So F is 0, no problem. So let's say F is 0. Then what else? G bar will be exactly E here and L. Okay, so exactly E. ये कितना आ रहा है E का?
.05 meter.
G is also same. And what else is pending? H on lift wall. So it will be 0.25 L2. Okay, so 0.25 L2 is how much? 2900 plus. See, this 0.25 L2 is still the face of the column plus this bar, which is going inside. So 200 minus 25. Plus L down, which is 450 minus 25 minus 25. ये कितना आ रहा है?
1.3 meter.
1.3 meters. Correct. So yes, E bar क्या है हमारा? E bar is 2T12, 2T12. G bar is 2T8 and H bar is 3T12. This is with respect to the main steel. Now we will go with the stirrups, right? Stirrups कितना है? T8 at 200 है. So it will be here and here, right? So stirrup for B1. So you should know the length of the bar. And this hook. So you know this is your 230 by 450. So cover is 25. So what is the length of the stirrup? 2 into 450 minus 25 minus 25 plus 2 into 230 minus 25 minus 25 plus this one is 80 plus 80. 8 into 10. ये कितना आ रहा है?
1.32.
Now numbers will be, see now how much detailing you should do, it depends on you as per the requirement of the project and say feasibility. See, you know that we take the dimension 50 mm from here. First stirrup is at 50 mm from this face. Again, this first stirrup will be 50 mm. So from length, you will subtract 50 here and 50 here, means 100. So instead of 460, we will take 4500. So 4500 divided by spacing of the stirrups is 200. See, 200. on both the sides. So 200 plus 1.
24 हो जाएगा
24 या 23? Okay, 24
24.
numbers.
24 sir.
Okay, 24 numbers. Now B2 stirrups. So B2, we will calculate the numbers only because the length will be same because the size is same. Is it same? Size is same, right? So numbers B2 length will be 1.32 meters and numbers will be 2900 minus 100. 2900 minus 100 is 2800 divided by 200 plus 1.
15
15 numbers. Okay. So these are the overall length calculation. We know that the tricky part is only length calculation. All other things are very easy. Now, if you want to do, you can prepare the table of this. And you can do, for example, let's say quantity. Or you can say here, you can write here, say bar tag. Okay. You can even write down the beam number, something like this beam number. So we will not do the calculation, just then bar dia, then numbers. Okay, and then kg per meter, and then total weight. So for example, let's say for B1, what kind of bar tags are there? There is E bar, F bar,
G
GH और क्या है F GH. अभी G है, then H में दो है, HC1 है, HC2 है, right?
yes sir
And stirrups भी है, stirrups को भी tag कुछ तो दे सकते हैं आप. We can say
S1 दे देते
S1, ठीक है, S1 करेंगे. S1 for B1, can give any name, S1 let's say. Now you know E का कितना है bar diameter? 12. B1 देखो, E का 12 है, नो 16 है क्या?
16 है
16 है और 2T 16 है, दो बार है. So 16, two numbers, kg per meter is 1.57 na? F कितना है? 16 है ना?
yes sir
One number,
G12 है
G है 12, नहीं G top 8 रहेगा ना? G top है ना full? 2T 8 है. So G is 8, two numbers, 0.39 kg per meter. HC1 12, three numbers, 0.89. I don't know, ये सही है क्या देखो. Then HC2 कितना है? ये 3T12 था. HC2 है 3T16. 16, 3, 1.57. Okay. And S1 का, one point is missing. Length कहाँ लिखा है हमने? Length तो लिखा ही नहीं. Okay.
kg के बाद लेंथ लिख
नहीं, यहाँ लिखेंगे length. So multiply करना पड़ेगा ना इसको. And then total weight. S1 bar diameter is 8. Numbers 24 है ना?
yes sir
24 numbers, and as it is 8 meter, 8 mm, 0.39 kg per meter. Now, what is the length of the stirrup here? 1.32 meters. HC2 ये ऊपर से ही लेंगे. E का कितना है? 5.78. F 3.45. G सेम ही है ना 4.78. HC1 1.755 and HC2 2.47. See, now I'm not going in calculation of this. Don't go in the calculation. Understand the process. So learning is understanding the process, but the calculation you can do on the calculator once you understand the process. So in the similar fashion, you can go with the beam B2 and you write down these tags and total weight you can get. So generally we use the Excel actually for such kind of calculation. So it is easy to do this. So we can do that in Excel also because there are many beams actually available. And you can prepare the Excel sheets also using the normal formula. You can put these tables and you can directly get the values. So whatever process I have discussed, say this span divided by spacing +1 is number. So you can directly put this kind of formula in this Excel and you can prepare your programs. And if you are using RCDC software for design, then it will give you directly bar wise all the quantities. Okay. So this is the quantity estimation for beams. Now we will go to the slab calculations. See, for other things here, it's very easy now. If you see this, say B8, 9, 10, 11, 12, see, it's a continuous. So these continuous columns are there, mid columns we can say, where there is a continuity. And whenever there is a continuity, the important point to be noted is on the continuity, see, at the end support, it is 0.1 L1, but at the continuous end, it is 0.15 L1. That is the difference. For other things, it is very easy, 0.25 L1, 0.25 L1. Means L by 4, generally we use term on site, L by 4, L by 4 like this. So this is very easy, L by 4, but at end 0.1 L1, at mid support 0.15 L1 respectively. Means if it is L1, it will be L1. If it is L2, it is L2 like this. Okay. I hope all of you are getting this. Now we will go to the, so अभी इसमें अलग कुछ है क्या नहीं है ना? Yes, regarding the shear wall details, I will keep it with you because you need to calculate all the lengths like this. So generally we get the details from the RCDC and it will do the calculation for us. And if I ask you to do it manually, it is still easy. You can measure this dimension from the AutoCAD and calculate the length of each hoop and links. And finally, you can calculate the steel, right? I'm not going in detail. Once you understand the concepts, it is same for all. Now, what else is pending? Slab. So slab is important now. So if you see this slab, okay, we will calculate the steel for S1 slab. Okay. क्या हो रहा है? Okay. Now, so can anybody tell me what kind of slab is this? Is it a continuous slab, simply supported slab, or what else? Where is the continuity? Where is the simply supported condition, boundary condition? So can anybody tell me this?
B21 is a B23 continuous slab.
Yes, 23 is a continuous because if you see this, see this span is like this span is like this. That's why over this beam, it will be continuous. Okay. Now this is an end beam. There is no slab here.
21.
B21, then B1 also there is no slab over here. So this will be simply supported, this will be simply supported, and this will be continuous. Again, B6 is also simply supported. Why? Because this slab is sunk slab. Please understand. That means the level of this S1 and S2 is different. That's why it is also simply supported. So let me write this is simply supported, simply supported, simply supported, and this is continuous. Okay. So this is the boundary condition. That means now let's see which detail we are going to use for this. So there is a standard detail. We are doing the bent up bar system like this here. So along short span 8 at 150 alternate bar bent up. Along long span at the bottom 8 at 200 alternate bent up. Distribution steel T8 at 200. It is a two-way slab. So 8 150 at the bottom along short span, 8 200 at the bottom along long span. So just remember this. Now we will see what detail we are going to use. So as we know that we are having one end simply supported and the other end is continuous. So this is a continuous slab detail and this is a simply supported slab detail. So in this direction, if I use the section like this, in this direction, let's say section BB. Okay. This is section BB and this is section A. Okay. So A section, this is a simply supported and this is continuous. So we will use the first detail. And for BB section, this is simply supported, this is simply supported. So we will use the simply supported section. So let me paste that first so that it will be easy for reference. This is continuous slab detail and the other one is simply supported. Okay. So for, okay. Section AA will be your continuous. I'll do one thing. Let's take section BB, which is very easy. Section BB. So this you'll use section BB here. Now in section BB, now the question is which one is the longer span and which one is the shorter span? Because what schedule is saying here, along long span and along short span. If you see the slab schedule, you can see over here along short span. That means you must know what is short and what is long. So let's measure the dimensions. Internal dimensions I'm measuring 2.89 and this one is 2.66. Okay, or let me do it in mm. 2660. So this is your See, deliberately I am going from the basic principles. And ये कितना है? 2890. 2890. Right? So you know these dimensions. Now section BB. See this section. So this L1 is how much? 2890. Yes or no? Section B. 2890 L1. Are you getting? सबको समझ में आ रहा है ना क्या चल रहा है?
Yes, sir.
स्लैब में थोड़ा सा स्लैब इज वेरी सिंपल एलिमेंट एक्चुअली बट डिटेलिंग इज अननेसेसरली कॉम्प्लेक्स बट जो है सो है. तो अभी अल्टरनेट बार बेंटअप्स. नाउ दिस हॉरिजॉन्टल बार, see this is your long span. So what is your steel along long span? T8 at 200 at bottom along long span. And that to what? Alternate bar bent up. So see, every word is important. Steel at bottom along long span, alternate bar bent up. So alternate bar bent up means, see, you can see here, this bar is there. This is going like this, it is bent and it is going straight here. And next bar is, it is straight here and bent like this. So alternate bars are like this. So that means I will say that this spacing of this bar is T8 at 200. Not 200, 400. It will be 400. This bar. And this bar will be T8 at 400. थोड़ा समझ के ले लो जिनको पता नहीं है. And at the center, how many bars will be there then? कितने बार रहेंगे यहाँ? ये 400 और ये 400 दोनों स्पेसिंग मिला के कितना होगा? Number of bars?
200.
200, right? So it will be this plus this will be T8 at 200. And what we require from the schedule? यही चाहिए ना हमें? So on site, the people will do like this. They will put this bar bent up bar T8 at 400 and this bent up bar T8 at 400. So total will be T8 at 200 once we sum that. Okay, on site. So this is the meaning of that. Now, what are these dots then? Dots का meaning क्या है ये नीचे वाले bottom dots? ये distribution नहीं होगा.
Long span steel.
So this will be your short span steel, right? Dots. ये जो dots है ना, this is nothing but short span steel. Where you will see this steel? In which section you can see? In this section, right? Continuous beam के.
AA.
Right. So A, so it will be your section AA. And this, let's say this is your section A. So section A में ये कितना distance है?
2660.
2660. और L2 कितना है? L2 लिया ना क्या हमने? ये आपका L2 है. Other slab S3 का. Let's measure this. One 1975. 1975. Width of the beam is 230. Now let's 1975. So it is 1975. 1975. Okay. So now these bent up bars are which bars? Short span, right? ये वाले कितना है हमारा short span में? T8 at 150 bottom along short span. Alternate bar bent ups. Okay. See again. Schedule. देखो. See this. Along short span, bottom steel T8 at 150 alternate bar bent up. Right. नाउ अगेन सेम थिंग, ये कितना आएगा बताओ फिर, ये बार T8 at दिस वन। अगर ये 150 रहेगा तो
300.
300 लेते हैं हम ना, और ये जो बेंट अप बार है, ये वाला बेंट अप, सो इट विल बी T8 at 300 अगेन, सो टोटली इट विल बी here it will be T8 at 150, and these dots are nothing but ये this steel, ये long span steel,
Long
whatever
span steel.
T8 at, ये जो है ना हमारा, ये dots है, so these dots are this 8 at 300 bars, so that's why I'm taking both the sections separately. Now you know, you are understanding now here, now you, where this bent up bar is started, it is started at the L1/7, okay. This is L1/7, then their bend will start and then it will go like this and it will have a L in the beam till the thickness of the slab. Again, same thing, L1/7 and this. Here you will see for the continuous beam, end support is L1/7 itself, but towards the continuous support, it will be L1/5. So we will start the bend from L1/5 and then this bent up bar will go in the next beam till L2/4. So this is your bar. So if I take this outside, it should look like this, this one, like this, this. Okay. So till this is your the end point of this bar. I hope everybody understood the detailing. Similarly, ये जो बार है L2 का, ये भी ऐसे इस बीम में जा रहा है, sorry इस slab में जा रहा है. This is your S1 slab, this is your S3 slab, and ये तो S1 ही है. Correct? Is it clear all of you? Detailing समझ में आएगा पहले, क्योंकि quantity निकालना वो बात की बात है.
Yes, sir.
Now thickness of slab is 125. So ये 125 है. मतलब दोनों सेम ही स्लैब एक्चुअली. ओके, नाउ लेट्स स्टार्ट विथ सेक्शन बी से स्टार्ट करेंगे, आसान है इसलिए. सेक्शन बी, नाउ टेल मी, अभी एक काम करेंगे, इसको क्या करेंगे, टैग करेंगे. समझो ये है बार ए, दिस बार इज बार ए एंड दिस बार इज बार बी. सो ए बार का कितना आएगा बताओ. What is the length of bar A? So length calculation is only tricky part. So what is the length of this bar A? कितना आएगा? This L. So L is 125 minus cover to the slab. I think ये कितना है cover to the slab? 20 है क्या? Drawing में कितना दिया? हाँ, slab में 20 mm है. Okay. So 125 minus 25 minus 25. ये this is your L length. This one. Now यहाँ से यहाँ तक कितना आएगा? पता नहीं अभी. So how to calculate this? एक काम करेंगे, यहाँ तक निकालेंगे, यहाँ से यहाँ तक, राइट वाला पहले यहाँ तक. तो ये कितना आएगा? 2890 माइनस L1/7, मतलब 2890 डिवाइडेड बाय 7. अभी ये माइनस किया, अभी ये बाद में निकालेंगे. एंड बिकॉज इट इज गोइंग स्ट्रेट, नाउ इट विल गो हियर इन द बीम इटसेल्फ, प्लस 230 माइनस 20 कवर, मतलब यहाँ से यहाँ तक. समझ में आ रहा है क्या चल रहा है? यहाँ तक मैंने निकाला, प्लस अभी ये बार, अभी ये कितना लेना पड़ेगा? यूजिंग ज्योमेट्री यू कैन कैलकुलेट दिस. 45 डिग्री लेके निकल सकते हैं ना ये लेंथ. कितना आएगा वो?
Height into √2.
हाइट इंटू √2. सो हाइट हमारा कितना है? 125 माइनस कवर करना पड़ेगा 20 मतलब 125 माइनस 40. 125 माइनस 40 ये आपका हाइट हो गया, इंटू √2 बोल रहे हैं आप. √2 करेक्ट. दिस इज योर डायगोनल लेंथ प्लस ये वाला लेंथ यहां से यहां तक. कितना आएगा फिर वो? यू नो इट ना, ये 45 डिग्री रहेगा तो ये आगे कितना गया है? 125 minus 40, right? So कितना आएगा लगभग 8 कितना 85. So L1 by 7 minus 85. Plus 230 minus 20 plus 125 minus 20. Is it clear?
Sir, what's root 2, sir?
So ये 45 degree है ना ये 45 degree का if you
Okay, okay.
calculate this length diagonal trigonometry ऐसे ये
Okay.
45 degree है ना, you know this dimension, ये हमारा क्या है 125 minus 40 है ना, ये height and this both are same. So if you do it by the tan and this sin theta cos theta, you can do that, right?
Okay, sir.
This square plus this square is equal to square of the this what diagonal Pythagoras. Okay, so you can do this. So ये कुछ तो आएगा यहाँ dimensions. I don't know. See, process is important. The numbers are not important. What now? Let B का क्या आएगा?
सर -85 पे से है,
ये क्या?
ये 289 के पास
This one?
सर आपका कर्सर ही नहीं पता चला किधर
ये?
तो
एक्सक्यूज मी सर,
Yeah.
यस सर।
ये सर आपका सर जो कर्सर है ना सर वो ड्राइंग पे दिख नहीं रहा सर, इसलिए मेरे को लगा कि मेरे साथ ही ऐसा है, पर वो शायद सबके साथ ये चीज हो रही
अरे
है।
हाँ, ये छोटा है क्या कर्सर? अभी कहाँ है
कर्सर
इसमें?
नहीं दिख रहा सर, पता नहीं चला
एक्चुअली
कहाँ
में
पे
सर
कौन सा
इसलिए
dimension
ड्राइंग
लिया।
में थोड़ी दिक्कत हो रही है सर, वो वैल्यूज को कैच करने में।
एक मिनट, कहाँ सेटिंग है? अभी क्या है, ये नया डाला है ना, इसलिए थोड़ा प्रॉब्लम हो रहा है। व्यू
सर सिंगल बार निकाल दीजिए, उसे पता चलेगा जो कैलकुलेशन कर रहे हैं रीडिंग की।
नहीं, अभी ये छोटा दिख रहा है मुझे भी, ये यहाँ है ना, क्या ये दिख नहीं रहा है ना?
नहीं
कर्सर?
सर,
कर्सर कहाँ रहेगा इसका? सेटिंग, व्यू, लेआउट, टूल बार्स, ऐसे चलेगा क्या?
अभी नहीं दिख रहा सर।
नहीं दिख रहा?
नहीं सर, वो अब रेडियस बढ़ाइए सर, 30 है तो उसको ज्यादा कीजिए।
ये दिख रहा है क्या? नहीं, पेन
आपको
नहीं
कर-
दिख रहा है, पेन की तरह दिख रहा है ना?
नहीं
मुझे
सर,
तो-
पेन आपका नहीं दिख रहा है।
अरे क्या हो रहा है प्रॉब्लम? अभी येलो कलर दिख रहा है क्या?
हाँ, येलो कलर दिख रहा है ये।
उसके सेंटर पे है कर्सर। इफ आई टेक दिस, द सेंटर ऑफ द सर्कल इज द कर्सर। दिख रहा है क्या सेंटर पे डॉट?
यस सर।
दिख रहा है ना? चलेगा, ये चलेगा क्या? ओके, लेट्स सी क्या होता है। नाउ लेट्स से बी।
तो इसको एक बार और समझा दीजिए।
हाँ, ये हुआ ना, अभी देखो ना, 125 माइनस यल निकाला ना हमने। ये
सर ये 125 ये लिए ना डेप्थ, बीम
ये
का
हमने
लिए।
ऑलरेडी लिया था क्या? ये यहाँ का डबल हुआ क्या? 125 माइनस 25 माइनस 25।
स्टार्टिंग ले लिए।
ये
Starting
स्टार्टिंग
में-
है ना हमारी, यल है ना ये।
हाँ वो बीम आप लिए सर, तब ना वो 25 माइनस किए हैं।
नहीं, वो समझ में आया। नहीं, यहाँ मैंने राइट को फिर से नहीं लिया कि ये 230 फिर से लिया मेरे ख्याल से। ये 230 तो चाहिए, -20 दैट इज ऑल्सो ओके, प्लस 125 ये है ना, ये नहीं होना चाहिए मेरे ख्याल से। ओके, अभी थोड़ा लेफ्ट राइट हुआ इसलिए प्रॉब्लम है। नाउ लेट्स सी, यहाँ देखो ये 125 माइनस ये वर्टिकल लेंथ 125 माइनस 25
कर्सर आपका नहीं चल रहा है।
नहीं दिख रहा अभी येलो।
येलो दिख रहा है लेकिन कर्सर चल नहीं रहा।
येलो दिख रहा है सर, पर वो मूव नहीं कर रहा,
नहीं,
वहीं
move नहीं
पे
हो
दिख
रहा है।
अभी ये देखो ना, ऐसे ड्राइंग पे दिख रहा है।
नहीं सर, वो नहीं दिख रहा है। वो हमारे में एक जगह स्टॉप है बस।
स्टॉप है क्या वो?
हाँ
अरे अरे अरे, अरे क्यों हो रहा है ऐसे?
स्मॉल डॉट है।
हाँ यहाँ कुछ तो है, रेडियस।
सर वो बिग बिग पेन कर दीजिए, इसका बॉर्डर भी बढ़ा दीजिए बस।
दिख रहा है अभी पेन?
हम्म।
क्या हो रहा है मेरी समझ में? लेट मी चेक। नहीं तो फिर ऐसे कैरी करेंगे थोड़े देर। ठीक है अभी कैरी करेंगे, लेकिन कुछ भी ये नहीं हो रहा क्या पॉइंट
नहीं सर, नहीं दिख रहा है।
अभी?
नो सर।
अभी ये ड्रॉ किया तो होता है क्या? दिखता है क्या ड्रॉ करने के बाद ऐसे?
कुछ नहीं दिख रहा है सर, आप कहाँ ड्रॉ करो वो भी पता नहीं चल रहा है।
नहीं नहीं ये देखो ना, ये दिख
वो
रहा है अभी?
ड्रॉ पता चल रहा है सर। और
हाँ
अभी लाइन 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 खींचे तो वो भी खींचा है, लेकिन आपको कर्सर कहाँ खुद मूव किधर ले रहा है पता नहीं चल रहा है।
नहीं ठीक है ना, अभी ये देखो सी 125 120 -25 -25 is this length, okay, this
Yes,
one.
sir.
Then 2890 अभी मैं यहाँ से स्टार्ट कर रहा हूँ, ये छोड़ दिया मैंने पहले, ओके, दिस वन आई एम कीपिंग. सो 2890 माइनस 2890 डिवाइड बाय 7. सो
Okay.
ये वाला मेरा लेंथ, ओके, दिस वन
ओके सर।
स्ट्रेट टिल दिस पॉइंट.
सर तो इंटू 2 होगा ना, दोनों साइड L/7
नहीं नहीं वो अलग बार है ना, वो बी बार में आएगा सब.
अच्छा।
बी बार नहीं निकालना, ये सिर्फ एक बार है ना सिंगल. बाद में +230 -20 मतलब ये वाला, ओके.
230 किसका डेप्थ हो
ये
गया ना
बी
बीम का।
ये बीम का विड्थ माइनस का वर्क.
Yes,
सो
sir.
ये वाला डिस्टेंस, राइट. नाउ दिस इज द, नाउ डायगोनल इज 125 -40, ओके,
ओके।
इनटू √2 मतलब ये डायगोनल डिस्टेंस प्लस 2890 डिवाइड बाय 7, L/7 माइनस 85 मतलब ये वाला डिस्टेंस 85 ये है ना. व्हाई इट इज 85? बिकॉज वर्टिकल ये 125 माइनस कवर 20 माइनस कवर 85 आएगा ना. नहीं कितना आ रहा है, सॉरी कितना आएगा ये?
1 मिनट सर।
85 यार है ना.
सर वो 85 है कहाँ से? टोटल तो L/7 है, तेल का जो लेंथ डिवाइड फिर 85 वो कैसे लेंगे?
सी ये माइनस कर रहा हूँ ना मैं.
जैसे 125 आ गया, ठीक है।
सी ये वाला डिस्टेंस मैं निकल रहा हूँ, ये वाला. सो ये कैसे निकालेंगे? ये यू नो द डायगोनल तो निकाला मैंने यहाँ, ये तो डायगोनल है. अभी ये
Yeah.
डिस्टेंस कैसे निकालेंगे? ग्रीन वाला. यू नो दिस L1/7 माइनस ये करना पड़ेगा ना, ये वाला यहाँ से यहाँ तक. गेटिंग?
तो वो उतना अब जो डिस्टेंस लिए वो कितना डिस्टेंस लिए सर?
85.
तो वो 85 आया कहाँ से? वो
वही तो ना. अरे यू नो दिस ना, ये कितना है मेरा? वर्टिकल 85 है ना, 125 माइनस डबल कवर. तो अगर ये 45 डिग्री एंगल रहेगा तो ये भी 85 ही रहते हैं ना. ट्रिग्नोमेट्री समझ में आ रहा है? हेलो,
यस सर।
ट्रिग्नोमेट्री पता है ना, 45 डिग्री रहेगा तो ये
हाँ
सामने
तो
वाला
10
ये
10 45 निकालने वो तो निकल
both the
जाएगा।
dimensions are same actually if there is a 45 degree angle. So I know, if I know the vertical depth which is same as this, okay, so this is your 85 and then your 230 minus cover. Vertical तो already हमने लिया है यहाँ.
यस सर।
ये 125 minus 25, okay. So this is the bar length A and then B will be, अभी B तो सेम ही रहेगा ना,
हाँ ये तो सेम ही रहेगा सर।
क्योंकि वो ऐसे यहाँ से सिर्फ उल्टा है बाकी कुछ नहीं. तो B will be same जो कुछ आएगा. So I am not going in the calculations, we want to understand the process. So this is your bar A, bar B will be same, यही रहेगा ये दोनों. Now we will see the next section, section AA. So अभी section AA में ये जो बार है, ये this one ये तो निकाल सकते हैं अभी बाय द सेम प्रोसेस, यस और नो? सेम ही प्रोसेस है ना ये। एंड दिस वन ओनली यू नीड टू ऐड दिस L2/4, ये वाला जो बार है ना ये, बाकी तो सेम ही है, ये डायगोनल ऐसे, ऑल कैलकुलेशंस आर सेम। इसमें कुछ है डाउट? We are only adding this L2/4 additional distance in this. So 1975 divided by 4 will be the additional distance. बाकी ये सेम ही है, L1 then point same procedure ये, समझ रहा है कि नहीं? Any questions in this section? Hello. Any questions?
No, sir.
Now, so this main steel you got, if it is a continuous, then you will add this in this portion only. Here, when it is not continuous, there is a L here. And if it is a continuous, then it continues in the next slab for L/4, right? So you will add that. Instead of this EL, you will only add this L2/4. So this is the main steel calculation. Now there is a distribution steel, don't forget. When there is a bent up like this, we also provide the distribution bars. Yes, these dots. So these dots or these bars are straight bars actually. So tell me what is the length of this bar? ये वाला, ये कितना आएगा लेंथ इसका? ये डिस्ट्रीब्यूशन बार का लेंथ क्या है? It is straight bar.
Three to 7.85 mm.
कैसे निकाला बताओ, प्रोसीजर चाहिए मुझे।
सर L/7 माइनस 35 पर देते, इतना दूर का डिस्टेंस निकल जाएगा।
नहीं नहीं, आई एम आस्किंग द लेंथ, नॉट नंबर्स। लेंथ कितना आएगा? दिस इज कौन सा लेंथ निकाल रहे वो समझ में आया ना? डॉट्स
सर।
का मैं बोल रहा हूँ, डॉट्स। डॉट्स आर इन द अदर डायरेक्शन ना। सेक्शन बीबी में जो डॉट्स दिख रहे हैं ये वाले, ये डॉट का लेंथ क्या है? गो इन द प्लान, सो दैट विल बी इजी टू अंडरस्टैंड। सो सेक्शन बीबी में डॉट्स दिख रहे हैं ना। So if you see the section DD, then the dots are like this. Yes or no?
Yes, sir.
ये वाला बार रहेगा मेरा, correct? So whenever there are bars in the slabs, they go beyond the beam, internal face, till the outer face of the beam. अभी इसका लेंथ बताओ कितना है? So ये मैं पूछ रहा हूँ. This is your distribution bar. What is the length of this? 2600 plus ये वाला 230 minus cover 20 plus ये वाला 230 minus 20. समझ में आ रहा है? So this is the distribution bar. which you can see in section BB. Section BB में देखा तो ये dots रहेंगे ना, distribution bars. And if you see the section A, then this will be your distribution bar. ये वाला. Correct. Getting this? So इसको मैं बोलता हूँ, let's say कि ये जो है ना, ये D1 है, समझने के लिए मैं D1, this horizontal bar and this vertical bar is D2. अभी D1 कौन से सेक्शन में कहाँ दिख रहा है मुझे बताओ. Who is D1? So ये D1 है ना? Yes or no?
B2 section में distribution.
सेक्शन BB में जो डॉट्स है वो भी D1 है, एंड सेक्शन A में जो डॉट्स है दिस वन, ये है D2. Yes or no? Correct? Slab is very easy for design, but unnecessarily डिटेलिंग में और साइट के लिए भी थोड़ा कॉम्प्लेक्स ही रहता है जनरली. ओके
सर हम आरसीडीसी यूज कर लेंगे ना, कौन
नहीं आरसीडीसी नहीं यूज करो, डोंट यूज इट. You should understand it. If you don't understand, please study that. RCDC ये सॉफ्टवेयर है, वो कुछ भी कर सकते हैं. Okay, so I recommend all of you please do it manually first. वो तो करना ही है आपको, बाद में करो, मतलब you can use the softwares once you understand the concepts. लेकिन ये पहले निकालो, हाथ से भी करो. ये 2-3 स्लैब सी इफ आई
ये तो बीबीएस निकालने का काम हो गया. बीबीएस तो के लिए तो खुद वहाँ साइट पे इंजीनियर करता है.
नहीं ये बीबीएस नहीं है, ये क्वांटिटी निकाल रहे. बीबीएस के लिए तो बहुत ही डिटेलिंग में करना पड़ता है. सी यू कैन डू योर शॉर्टकट्स नाउ वंस यू अंडरस्टैंड द कंसेप्ट. क्या कर सकते हैं आप, ये सिर्फ आपको ये डायमेंशंस निकालने हैं ना, बाद में क्या करना है. इट्स इजी ना, देन पुट इन द एक्सेल एंड इट्स वेरी इजी. ओके सो वी हैव डन द स्लैब्स. बाकी क्या है इसमें. सो I think this is the quantity calculation for RCC structures. And for homework, I'm giving you do this for the shear wall calculations, stirrups and main steel, and this also, staircase. Staircase में अभी बताता हूँ मैं क्या है reinforcement. Staircase ST bar 175 thickness, distribution is 8 at 200 and main steel is T8 at 150. For the staircase. अभी staircase में यहाँ लिखा है क्या, नहीं अभी ये T12 at 125 है. So ठीक है, अभी स्टडी पर्पज के लिए लेंगे. So I'm not taking that, we will only discuss. Now let's say main steel is sloping. All of you know that the staircase slab is one-way slab along the long span, right? So if you see the staircase plan, go into the plan, floor plan. Then what is the spanning direction? This is your spanning direction along long span, yes or no? So distribution is horizontal and main steel is along the long span, that is sloping slab, along the sloping direction. So here also you can see the sloping direction bars are T12 at 125. Okay, so these are the sloping bars. And here you can see, now see the bar, how the bars are developed. From here, then here, look at the red line. Then it is going like this straight or sloping, and then it is going till the top of the slab, and then there is a bend like this. Getting this?
Yes,
So
sir.
this dimension is LD. Okay, from this joint till this point. Then you can see there is a bar. So this is your TT T12 at 125 main steel along long span. Then there is a bar. Let me draw it in blue color. So this is also one bar like this, sloping, then going horizontal. And then there is a L also here. It is going L in the slab. Here also it was L. So this dimension is generally again same. From the corner it is LD, right? From here to here it is LD. And then there is a bottom bar. You can see. Let me draw in red color. This bottom bar, there is a L over here, then horizontal bars. And again going sloping. Again, this is LD from this corner joint. Here to here it is LD. LD is how much? 60 times diameter of the bar. So if it is a 12 mm, then it will be 720 mm LD. You just refer the drawing. So all these diagonal bars are 12 mm bars, which is a main steel. Again, here you will see there is a bar like this, then horizontal top bars. Now it is going crossing this. And then it is going like this here. And there is one more bar over here, which is this one horizontal, sorry. This one horizontal, then diagonal like this. Again, it is LD. So the detailing in staircase is very much important. Now you can calculate by using the geometry the length of each bar. So no problem. Once you can take the dimension from the drawing, this dimension. This diagonal you can, how can you calculate the diagonal dimensions? Using Pythagoras, right?
Yes.
Or if the drawing is already drawn in the AutoCAD, directly measure it. If it is in the drawn. If it is not drawn, then you can use Pythagoras. And each and every dimension is clear now. And then the other bars are there. Don't forget that there are.
Sir,
Yes, yes.
sir, bottom blue one, how much?
Bottom,
Bottom blue and straight horizontal.
this one.
Yes, blue. Till the end of the beam or in between, middle.
This one you are saying?
Yeah, yes.
Yeah, this is still here, na? This one LD.
The distance towards left side.
LD.
Okay.
Yeah. See, whenever there is a junction, see this. Do you know why we are crossing these bars? Why we are crossing these bars? From here and then again here, this bar. Why there is a crossing near the junction? Again, here also you will see there is a crossing here. There is a crossing over here. Anybody, please? कोई बता सकते हैं ऐसे cross क्यों किया है? हाँ?
Avoid crack.
To avoid the cracks, yes. So there is a possibility of cracks because of the geometry of that section, right? So once there is a load, downward load is there, and due to that, this angle may get increase, or there is a possibility of crack. So I will show you the crack, then you may understand that. As there is a load on the staircase, you know that this angle will try to open up and there will be crack like this. So there will be crack like this. Then this angle will also try to open up and there will be crack like this. To avoid these cracks, we are continuing the steel like this. So ऐसे आगे लेके ऐसे जा रहा है. And this bottom bar also I am taking and going like this, right? So there is this crack, you know that crack is developed due to the tension. And once you provide the steel along the perpendicular to the crack direction, then that crack will not happen. Similarly, here we are taking these bars ahead. And again, this bar, the dimension you asked, we are only putting that bar to avoid the cracks. This one, right?
Yes, sir.
So this is the detailing for the staircase. And next point is that there are distribution bars. These dots are there. So don't forget, we have shown only with respect to the spacing. But there are dots like this. They are straight bars. What is the length of this bar? Blue. distribution bars. These are distribution T8 at 200, let's say. Distribution as given in the drawing. What is the length of this bar?
So span of trade minus cover.
Yes. Correct. So I have asked the dimension, which is this one. Because now these beams are at different level and the sloping, as it is a sloping slab, it cannot pass in the beam. Please may remember this. At least in this sloping portion. Okay, so yeah, aise rahega. This will be your from here to here. Okay, so this width, whatever, let's say it is 1 meter in our case, 1000 mm, let's say. So 1000 minus cover, as you said, on both the sides, 20 minus 20. So this will be your distribution bar. Similarly on the left side. And one more point, actually, we generally put the L till the depth of the slab only, generally. Now this was the mid landing. Yes, one point is that this is a mid landing beam. And this is your floor beam. And you know that there are 2 flights for the dogleg staircase. So actually it starts from the plinth beam first flight. From the plinth beam till the mid landing beam. And then again from the mid landing to the floor level. So in the plinth beam also you want, please note this bar is also required, right? All other details are same, crossing the junction and all these things. So got this? समझ में आया सभी को? So do the practice. Any questions?
सर
Yes.
वो सर एलिवेटेड का एक क्लास रख देते हैं.
हाँ करता हूँ ना, मैं करता हूँ, अरेंज करता हूँ. वो थोड़ा अभी शेड्यूलिंग थोड़ा टाइट है इसलिए ये कर रहे हैं हम. आई विल अरेंज इट, डोंट वरी. टिल दैट जो सिखाया उस पे प्रैक्टिस करो.
हाँ तो वो तो कर रहा हूँ सर. वो सर को मैंने मेल किया था, निखिल सर को. वो सर्कुलर वाटर टैंक का एक बार चेक करने के. मेरा क्रैक विथ माइनस में जा रहा है, इसलिए मैं उनको भेजा था. बाकी सही है.
जा सकते हैं माइनस. वो एक्सेल शीट में क्या?
हाँ एक्सेल शीट में
जा सकते हैं. माइनस इज नो प्रॉब्लम. So the important point in quantity calculation of reinforcement is reading the drawings and reading the standard details like this. So ये सब important रहते हैं जिसमें bent up, hook length, then lap length, okay, location of lap, ये वाले location of lap, then LD, what is LD? So these are the only things. Then hook length of the stirrups. These are typical things in the structural drawings. So it is applicable for buildings or footings, columns, or it may be retaining walls or anything. So you can do that. So as a practicing engineer, the important point I think is the drawings, structural drawings. Once you understand the analysis basics, design basics, the final part is always drawing, because this is the only document which goes to the site for construction. So site people or construction team will not bother what have you done in the softwares or in calculation office. They will not check. They will only bother whether the dimension is correct, can it be constructible, and is it correct from construction point of view. So the dimensioning of the drawing is very much important. The level of the drawing or level of the section. For example, if this is the staircase, then the level should be mentioned over here. Then yes, you ask, I think Suleka has asked me regarding what is the dimension. So there has to be written that LD dimension and everything in the drawing. Now it is not here, but it has to be mentioned. Otherwise, site people will have a question. Ki what should be this length, right? So it has to be mentioned. Each and every dimension should be mentioned in the drawing, so that there will not be ambiguity on the site. Okay. Any questions?
सर एक मालूम बता सर एक प्रैक्टिस के लिए बिल्डिंग का कोई ऑटोकैड फाइल भेज सेंड कर देते हैं ग्रुप में।
क्या करना है मतलब आरसीसी बिल्डिंग का क्या मॉडलिंग करना है कि क्या करना है?
सर वो एनालिसिस करना है तो ऑटोकैड और पोर्टफोलियो एक बनाना था इसलिए वो बोल रहा था।
हाँ 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 हाँ। कितना दे दूं मतलब आप स्टोरी 1 स्टोरी 2 स्टोरी 5 स्टोरी ऐसे मतलब?
सर G+12 स्टोरी 13 14 दे दे, हाई रेंज का ही ज्यादा बेटर।
लेकिन उसको टाइम लगेगा आपको, देखो मतलब आई डोंट नो, you check it out ki can you do it, because if you are putting in the portfolio then it will take time, but okay I will share some drawings, check करो उसको ही multiply करो अगर कम रहेंगे ज्यादा रहेंगे तो okay।
उसको ही कम बेस कर
हाँ
देंगे
वैसे करो, हाँ स्टडी के लिए तो है ना, चलेगा।
क्योंकि अब सर इंटरव्यू देने का समय आ गया तो थोड़ा तो।
हाँ करो ना। where are you currently say staying?
सर पटना।
पटना में, और कहाँ जॉब चाहिए मतलब?
कहीं भी
What
कर
jobs?
सकता हूँ, कोई ऐसा मेरे साथ नहीं है कि मैं अगर कहीं भी
हाँ।
मिल जाए तो मैं जा सकता हूँ।
Okay, okay. Okay, discuss me on phone, maybe within 2 days. We'll check it out. CV बना रहे हो क्या?
सीवी सर मेरे पास एक पहले से बना हुआ है उसमें।
I will guide you क्या करना है इसमें, ऐड कम ज्यादा। हमारा ट्रेनिंग का कोर्स का पूरा उसमें आना चाहिए। शेयर दैट विद मी।
ओके सर।
हमने जो शेयर किया है ना वो मुझे चाहिए, और जो नहीं रहेगा तो आई विल टेल यू कि ये ऐड करो वो ऐड करो।
ओके सर, इसमें ये इंटर्नशिप का डिटेल पूरा दे दूंगा।
हाँ करेक्ट, वो पूरा मतलब स्ट्रक्चर्स ऐड करो। बिल्डिंग्स हमने 5 स्टोरी बिल्डिंग लिया था, टावर लिया था, वाटर टैंक्स लिए है, स्टील स्ट्रक्चर, जो जो लिया है ना हमने वो सब उसमें स्ट्रक्चर्स आने चाहिए सीवी में, क्योंकि आपने जो किया है वो दिखना चाहिए ना सभी को।
ओके सर।
डिजाइन बेसिस रिपोर्ट किया था सब, और एक अटैचमेंट भी बनाओ, सभी का प्रिंट निकालो। फॉर एग्जांपल अभी ये ड्राइंग बनाया था हमने आई थिंक, तो ये टेक आउट दिस ड्राइंग प्रिंट्स एंड हैव विथ यू, लाइक प्रोजेक्ट रिपोर्ट जैसे रहता है ना कॉलेज का,
हाँ सर।
उसकी तरफ से वो पोर्टफोलियो बनाओ एज एनेक्स्चर करके। मतलब योर सीवी विल बी 2-3 पेजेस और 4 पेजेस, बट देयर विल बी अटैचमेंट कि उनको दिखाने का इंटरव्यू में कि मैंने इतना सब किया है करके। समझ में?
ओके।
बिकॉज सी वॉट एवर यू लर्न यू शुड प्रेजेंट ऑल्सो, अदरवाइज फिर समझ में कैसे आएगा इंटरव्यूअर को कि आपको आता है करके। सो देयर इज अ प्रेजेंटेशन स्किल ऑल्सो
ओके
in the paper, on the paper and in the interview also. So I will tell you, just start preparing that.
ओके
Okay,
Yes, sir.
चलेगा, ठीक है। Okay, so thank you all.
थैंक यू सर।
Thank you, sir.
Thank you.
Thank you and good night to all.
Thank you,
Yes,
sir.
sir.
Good night.
Good day, sir.